So these are the two vectors that are present, vector A and vector B. Now, how actually the parallelogram looks like? We have seen the parallelogram looks like this. So if these are the sides, one side is this and second side is this. These are the sides of parallelogram. Then the resultant is given by the diagonal of the parallelogram. These are the sides, these are the adjacent sides. So resultant, how is the resultant given? You construct it, you make it a full parallelogram, and this is how the resultant is given. Now, the question that came was that two vectors are present and they have certain angle between them. And they are coinitial vectors. See, what is the meaning of the word coinitial? Co-initial means having the same starting point.
Yes, yes, ma'am.
Now, if two vectors are co-initial, like this, all these vectors are co-initial vectors because these have a common starting point as O. This is a common point. Now, if two vectors are co-initial and they have some angle between them, so it means it is like this only. So if this is the case, it means we can apply the parallelogram. The condition for parallelogram law is fulfilled here. So the answer was parallelogram, not the triangle law or any other law. When, see, how do we use it? How do we use it? I'll tell you why. What's the difference? Suppose let us talk about the triangle law. Now in triangle law, two vectors have to be taken in the same order. Same order means, see, when we represent a vector, this is how a vector is represented. This part is the tail of a vector and this part is the head of a
Head of
vector.
the vector.
Yes. So when we say same order, means tails, heads, and then tails, heads. This is what we say the vector is in the same order. So look, this is not coinitial. They do not have the same starting point, right? These are not, both of these are not
Yes, ma'am.
coinitial. Yes. So here the resultant is given by the opposite side of the triangle, that is the closing side. And that too taken in the opposite order, see? So resultant is given by closing side of the triangle in the opposite order. Look, this was in same, these were in the same order. This is in the opposite order, where the head was present. Now head and head are coinciding, while head and tail have to be present. So this is the triangle law. So you should identify if two vectors are looking like this, that means you can apply triangle law. If two vectors are looking like this means you can apply the parallelogram. But one thing is there, see, both of these have the same method for calculation of magnitude and direction. Like I'll tell you, suppose this is the resultant and you want to find its magnitude. Two vectors are there. So how will you take? P square plus Q square plus 2PQ cos theta. This is how you calculate. This is the vector 1. This is vector 2. And theta, what is theta, Abyaz?
Angle.
Angle between?
Angle between two sides.
Yes, angle between two sides. So this is angle between the two vectors. Now, your vectors are always incomplete without a direction. So we need a direction also. So see, this is what? This is basically the magnitude of the resultant. This is the magnitude of the resultant. Now for the direction, look. Suppose this is, let's say, A, or let me make this as A. This is vector A, this is vector B. And rest of the story was the same, that this is the diagonal which is representing the resultant, etc. The angle between the vectors is theta, as discussed already. Now for the direction, what you do, you choose an angle beta with any of these.
Yes, ma'am.
Like I am taking beta here. So the axis with which the angle is made, this becomes A and the opposite one becomes B. So what is the formula that you have to use? Tan beta is equal to B sine theta by A plus B cos theta. What is A? Angle is near to this vector. And B means the far away vector. This is the far away vector. So this is how you will choose. Like here A and B are given, then you will have the values also. So what does this give? This entirely gives the direction of the vector. See, I hope you've studied everything in class 11th. It's just a revision for you if you have forgotten anything. Got it,
Yes,
Abyaz?
yes, ma'am.
Till here, everything is clear?
Yes.
Okay. You write it from here. Just make the heading as a revision or write bridge course. And please start writing. And when you will keep on doing it, you can just keep on texting me done. I'll scroll it.
Ma'am, can you scroll? Ma'am, you can scroll more. Ma'am, you can scroll more. Ma'am, scroll more. Ma'am, you can scroll more.
Okay, Abyaz, let's practice a question on this.
Ma'am, can you explain this question? I'm not getting the answer.
Okay, see, if you get such kinds of questions, what you have to do, like velocity, you have done in your class 11, but see, vectors are present in class 12th also. So instead of velocity, it can give you electric field, electric forces, like this in class 12. So that's why we are studying this. Look, this is saying two velocities. They are inclined at this angle. Means two
60
velocities
degree.
are present, 1 meter per second, 2 meter per second. This is V2. This is V1. An angle between them is 60 degree. So see, this is our vector 1. Just a minute, Abyaz, wait. Just a minute.
Okay.
So here what is happening? Yes, Abyaz. See, this is our first vector, this is our second vector, and between them the angle is 60 degree. So when we write the resultant's magnitude, the formula is first vector square plus second vector square, then first vector into second vector into 2 into first vector into second vector into cos theta, means cosine of angle between.
Yes, yes, ma'am.
Now we'll put the values here. Look, this is 1, so 1 square. This is 2 square. 2 into 1 into 2 into cos 60 degree. What's cos 60 degree, Abyaz?
Uh, 1/2.
Yes, 1 by 2. So let's see. 1 square will be 1. 2 square will be 4. Now this is 4. 2 into 2 is 4 into half, as you said. See, this 2 will cancel this 4. So what are we left with? 4 plus 5, 6 plus 1, 7. Root 7 Newton. This is the magnitude of the resultant.
Okay, ma'am. Okay.
Okay. And for the direction, you can take any of it with beta. Like suppose I take this with beta. So this becomes A, the one which is near the angle, and the one which is far away becomes B. So look, this will be tan beta will be B sine theta by A plus B cos theta. B is 2. This is 2 sine 60 degree by 1 plus 2 cos 60 degree. So we know 2 sine 60 degree is root 3 by 2.
3/2.
Yes, 1 plus 2 into cos 60 degree is half. This half gets cancelled, this 2 gets cancelled. So what we are left with?
Root 3/2.
Yes, root 3 by 2. So we can say beta is tan inverse root 3 by 2. Got it?
Yes, ma'am. Understood.
Okay, you write down the solution. And see, when you want me to scroll now, you can just simply say, you can just simply text me, done. I'll read it. Okay. And I'll give you more question that you will solve and tell me.
Okay, ma'am. Hello, ma'am. Can you hear me? Can you hear my voice?
Yes, yes, Abyaz, you're audible.
I got disconnected. That.
Yeah, no issues. Did you write this or you still writing?
No, I wrote this.
Okay. A similar question I am giving you. Now you practice that and tell me the final answer.
Okay, ma'am. Ma'am, I got the answer. It is root 37 and
Direction? Yes, that is right. The magnitude is right. Very good. It is root 37 Newton. What's the direction?
direction I didn't find. I just found this one. There is a
Okay,
difference.
okay. Direction you can tell.
Ma'am, is it root 3 by 2?
Yes, right. So see, this part is clear. I think we need not practice this one. Now you'll be able to remember this parallelogram law, Abyaz.
Yes, ma'am.
Oh, there was one more question where you were lagging. That was regarding the resolution of vectors. But before we start with that, just one more thing. See, if when you have forces present and some sort of force acts on a body of mass m, so when the acceleration is asked to you, you have to recall Newton's second law. F is equal to ma. So from here, the acceleration is equal to the force by mass.
Okay.
This is the acceleration. This is the force. And this is the mass. Because in the test also, I had asked a question where the force was calculated, and means you had to calculate the force, and then from that that resultant force was acting on a mass of 2 kg, so you had to tell the acceleration. Whatever is your answer, like you're getting root 7 as the answer, and that in the first question you got root 7.
Yes,
This
ma'am.
one we got root 7. So if this force acts on an object whose mass is 2 kg, so acceleration will be, yes, Abyaz.
Yes, ma'am.
If force is root 7 Newton, mass is 2 kg,
Yes.
acceleration should be,
Uh, 2 by root 7.
no. See, that's what I was telling you. The force is equal to ma. Acceleration will be force by mass. Root 7 by 2 meter per second square.
Okay, okay.
What did you see? You need to remember the external force that acts on a body. This is directly proportional to rate of change of momentum. Now, once we have the momentum in our system, m into v, using this, we put it in the formula for the calculation of acceleration. And what do we get? Finally, the equation becomes F is equal to ma, because your acceleration is dv over dt. Got it?
Yes, yes, ma'am. Got it.
Okay. Now coming to the Cartesian form. I think this is sufficient from this side. Let's come to the Cartesian vectors. Okay, what is the unit vector along x-axis?
Unit vector along x-axis.
Yeah,
I'm not sure now.
it is.
No, I'm not sure about.
Okay, see, I cap. Remember? I cap, j cap, k cap. What is I cap? It's the unit vector along x-axis. So see, Abyaz, if you have positive x-axis, you will have plus I cap. If you have negative x-axis, you'll have minus I cap. Similarly, when we're talking about j cap, it's the unit vector along y-axis. So similarly, if you make this positive, this is plus j cap. If this is negative, this is minus j cap. Last one. This is the unit vector along z-axis. So this is positive means plus k cap, negative means minus k cap.
Minus k cap.
Okay. So these Cartesian vectors are very important. Just copy down this.
Ma'am, finished.
Completed?
Yes, ma'am.
All right, Abyaz. So see, now I have to start. I'll be discussing. I need one more class where we'll complete this. So one more class of bridge course is needed. And then I'll start with the 12th class portion. So I think that I'll complete in the next class because not much time is left. We'll not be able to complete it. So unit
Okay.
vectors are left and the calculus part. Okay.
Yes, ma'am.
All right then. Thank you.
Okay.